It happened in a place that wasn't supposed to shake. Not like this. Not at this size. On June 8, 2026, the floor of the southern Gulf of Mexico cracked awake, and a magnitude 6.1 earthquake tore through water that geologists had long considered one of the quietest stretches of seafloor on the planet. The epicenter sat roughly 65 miles west-northwest of Mantua, Cuba, in the province of Pinar del Rio, far out under open water, far from any coastline that anyone expected to rattle. And yet, hundreds of miles away in Florida, people felt the ground move under their feet. Office workers in Miami stopped mid-sentence. Coffee trembled in cups in Tampa. And in that single moment, a region that had spent decades believing it sat on solid, stable ground was forced to confront a question nobody in Florida ever asks. What was that? And why did the Gulf just wake up? Here are the hard numbers, because the numbers are the story. Magnitude 6.1. Depth somewhere between about 6 and 10 miles below the seabed. Shallow, which matters enormously, and we'll get to why. Time: midday, when buildings were full and streets were busy. Epicenter: out in the southern Gulf, west-northwest of Mantua in Pinar del Rio. No tsunami, no coastal evacuation order, but shaking felt across an astonishing footprint, across the Florida peninsula, more than 400 miles from where it struck. And one detail that turns this from a headline into a genuine scientific event. This is now the largest earthquake ever recorded in the Gulf of Mexico with modern instruments. Modern seismic monitoring in this region dates back to roughly the 1950s. That means in over 70 years of careful instrument-grade record-keeping, nothing in the Gulf has ever measured this big. Nothing. Until now. Let that sink in for a second. The Gulf of Mexico is enormous. A vast basin ringed by the United States, Mexico, and Cuba, crossed by shipping lanes, lined with oil platforms, watched constantly. And in all that watching, scientists have logged only a tiny handful of earthquakes here that reached magnitude 5 or greater, 5, maybe 6 in the entire recorded history of the basin. That's it. The Gulf is not a place that shakes. It is, by reputation, a place that sits still. So when a 6.1 ruptures out there, bigger than any of those rare 5s, it doesn't just register on a seismograph. It registers as something that, by the old rules, almost shouldn't have happened at all. And it gets stranger. Seismologists who pulled up the historical catalog found something that stopped them cold. Within 250 kilometers of this epicenter, that's a circle more than 150 miles across, there had never been a recorded earthquake above magnitude 5.0. Not one. This wasn't a known danger zone that finally went off. This was a stretch of seafloor with essentially a blank seismic record, a quiet patch on the map, and it produced the largest Gulf quake ever instrumentally measured. That is the kind of surprise that makes researchers lean toward their screens and start asking hard questions. Because earthquakes are not supposed to come out of nowhere. They come from faults, from plate edges, from places where the Earth's crust is being ground, pulled, or shoved. And this one struck in a place where, on paper, none of that should have been happening. That's the first piece of what makes this event so odd, and it points to something seismologists genuinely find unsettling, not because it's apocalyptic, but because it's poorly understood. This quake did not happen along the edge of a tectonic plate. It happened in the interior of one. Most of the big earthquakes you hear about, the ones that flatten cities and trigger tsunamis, occur where two plates meet and collide and slide. The ring of fire, the trenches, the great fault lines, that's where the action is. But every so often, the Earth breaks far from any boundary, deep inside the body of a plate, on ancient buried faults that nobody knew were still capable of moving. These are called intraplate earthquakes, and they are some of the least understood events in all of seismology. Rare, but not unheard of. And this June 8th rupture appears to be exactly that kind of event. A stress release inside the plate, far from where the rules say it should occur. But before we go deeper into the science of why this happened, you have to understand what it felt like. Because for millions of people who have never experienced an earthquake in their lives, this was the moment the ground broke its promise. In Miami, the towers swayed. Inside the Stephen P. Clark Government Center, that distinctive sensation, the slow, sickening roll that anyone from earthquake country knows instantly and everyone in Florida had to learn in real time, sent people toward the exits. The building was evacuated, a metro rail station was emptied out. Workers stood on the sidewalks under the Florida sun, phones out, looking at each other, asking the same thing. Did you feel that? Was that an earthquake? Here? Because that's the thing about Florida. Earthquakes are not part of the script. They're not in the building codes the way they are in California. They're not in the cultural memory. Florida residents prepare for hurricanes. They board windows. They track cones of probability for days. But the ground itself? The ground is supposed to be the one thing that stays put. And on June 8th, for a few long seconds, it didn't. The shaking didn't stop at Miami either. Reports flooded in from Tampa, nearly 400 miles from the epicenter, from Orlando, deep in the interior of the state, from Jacksonville, up near the Georgia line. People in high-rise apartments felt their furniture creak. Hanging lights swung, pets bolted. Across the peninsula, a quiet, eerie ripple passed through the bedrock. The energy of a rupture that began far out under the Gulf and traveled, almost effortlessly, across an entire state. And the reason it could travel that far, the reason a quake centered near Cuba could rattle a glass in central Florida, comes down to a single, crucial detail about how deep it struck. And that detail is where this story really begins to open up. Because depth in seismology changes everything. This earthquake struck shallow, somewhere in the range of 6 to 10 miles beneath the seafloor, and shallow earthquakes have a particular signature. The energy doesn't dissipate gradually through miles of overlying rock before it reaches the surface. It arrives close to full strength, and then it spreads outward across the crust like a stone dropped flat onto still water. A deep earthquake might rattle a small region intensely. A shallow one of the same size can be felt across an enormous footprint, and that's exactly what happened here. There's a second factor too, and it's a quiet one. The geology of the eastern United States itself. The crust beneath Florida and the southeastern states is old, it's cold, it's stable, and counterintuitively, that stability is precisely what lets seismic energy travel so far. In the fractured, broken-up crust of the western United States, earthquake waves lose their energy quickly, scattered and absorbed by all that geological chaos. But in the ancient, intact, glassy hard rock of the east, the waves keep going. They ring like a struck bell. A moderate quake in the east can be felt across an area many times larger than the same quake out west. So you take a shallow rupture, you put it under the Gulf, you send its energy across some of the most efficient seismic conductor rock on the continent, and suddenly, a magnitude 6.1 near Cuba is making office workers in Miami file down the stairwell, and apartment dwellers in Tampa watch their ceiling fans sway. Now here's a relief in the middle of all this, and it matters because the word earthquake near an ocean sends a very specific fear up everyone's spine. There was no tsunami threat, no warning issued, and the reason comes down to the way the fault moved. Tsunamis are born when the seafloor itself is shoved vertically, when a slab of ocean bottom suddenly lurches up or drops down, displacing the entire column of water above it and launching that energy outward as a wave. This rupture didn't do that. The motion appears to have been the kind that shifts the ground horizontally, side against side, rather than heaving the seafloor up and down. No vertical displacement of water, no tsunami. The shaking was the whole event. And for the coastal cities ringing the Gulf, that distinction was the difference between a frightening morning and a catastrophe. But strip away the relief, strip away the swaying buildings and the rattled nerves, and you're left staring at the part of this that genuinely unsettles the scientists. Because the headline here isn't just that Florida felt a quake, it's where this quake came from. Look at the map. Run your eye along the seismic hot zones of the Caribbean. There is activity down there, a whole arc of it, running along the boundary where the North American plate grinds against the Caribbean plate. That's a real, recognized, active seismic zone. Eastern Cuba sits much closer to it, which is why eastern Cuba is the seismically restless part of the island. In 2020, a powerful magnitude 7.7 earthquake tore through the sea between Cuba and Jamaica, right along that boundary. That one made sense. That one was the Earth following its own rules. This one did not. This June 8th rupture happened in western Cuba, in Pinar del Rio province, out under the southern Gulf, away from that plate boundary, inside the plate, in a place where the rulebook says big earthquakes simply shouldn't be brewing. And the numbers underline just how strange that is. Before this event, no earthquake above magnitude 5.0 had ever been recorded within 250 kilometers of this exact spot. Not one in the entire modern instrumental record. This wasn't a known fault firing again. This was, as far as the instruments are concerned, a complete surprise. A rupture out of a quiet patch of crust that gave no warning, fit no pattern, and announced itself by becoming the single largest earthquake ever measured anywhere in the Gulf of Mexico. So what could possibly cause a magnitude 6.1 to detonate in the middle of a plate far from any boundary, in a place with no history of large quakes? The answer lies in something hidden deep below. And it's the same uncomfortable mystery behind some of the most surprising earthquakes in history. Buried inside every continental plate are ancient faults. Old wounds, scars from a time, sometimes hundreds of millions of years ago, when continents were tearing apart or slamming together, when oceans opened and closed, when the geology of the planet looked nothing like it does today. Those old faults didn't disappear. They healed over. They got buried under layers of younger rock and sediment. They went quiet. For ages, they sit there, locked, invisible, doing nothing, forgotten by everyone except the rock itself. But the entire plate is under stress, all the time. The slow, relentless push of plate tectonics doesn't only build pressure at the edges, it transmits force across the whole interior, squeezing and straining the crust even in regions that look perfectly stable on the surface. And on rare occasions, that built-up stress finds one of those ancient buried weaknesses and reactivates it. The old fault, dormant for millions of years, slips. And because nobody knew it was there, because there's no recent history of movement, because it doesn't show up on the maps of active zones, the resulting earthquake seems to come from nowhere. That's the leading explanation for what happened beneath the Gulf. Somewhere down in the deep, forgotten architecture of the North American plate, an old fracture that the rules said was finished found a way to move again. And the most honest thing seismologists can say about events like these is that we genuinely don't understand them well, which is exactly why this one may warrant much closer investigation in the months ahead. Because here is the uncomfortable truth about intraplate earthquakes: they are some of the hardest events on Earth to forecast. At a plate boundary, scientists at least know where to look. They can map the trench, measure the strain, count the slow creep of one slab grinding past another. They can say, with real confidence, this is a dangerous zone. But the deep interior of a plate gives almost nothing away. The buried faults don't broadcast their location. They don't build measurable bulges at the surface. They sit silent for so long that they fall off every hazard map until one day, without rehearsal, they rupture. And that is precisely why a single magnitude 6.1 in the middle of the Gulf has so many experts paying attention. It's not just one quake, it's a reminder that the rulebook has blank pages and that we still can't read the parts of the crust that matter most. Now look at where this leaves Florida. The state has almost no faults of its own. The ground beneath Miami, beneath Tampa, beneath Orlando is geologically calm in a way most of the world is not. When Floridians feel the earth move, it almost never starts beneath their feet. It arrives from somewhere else, rolling in from Cuba, from the Caribbean, from a rupture out in the Gulf. That's exactly what made June 8th so jarring. People weren't standing on the source. They were standing 400 miles away, and the planet still reached up through the floor and touched them. And because Florida sits on thick, soft, sediment-rich ground, those long-traveling waves don't just fade out politely. In places, they get amplified. The soft layers shaking like jelly on a plate, magnifying motion that should have been almost gone by the time it crossed the state. So what comes next? The United States Geological Survey was clear. After an earthquake this size, aftershocks are likely. That's not speculation. It's how the crust behaves. When a fault slips, it doesn't simply lock up and go quiet again. It redistributes stress to the surrounding rock, and that rock answers back, sometimes for days, sometimes for weeks. Most of those aftershocks will be small. Many won't be felt at all. But in a region with so little history, even a modest follow-up could send people in Pinar del Rio, and possibly across the water in Florida, feeling that unsettling sway all over again. The watch isn't over, it's just quieter. And there's a wider picture worth holding in your mind. Less than 24 hours before the Gulf cracked awake, a powerful magnitude 7.8 earthquake struck the Philippines, on the far side of the planet. Two major quakes, 2 oceans apart, in a single day. It's tempting, almost irresistible, to wonder if they're connected, if the Earth is somehow waking up all at once. But the honest answer is no. There is no fault, no wave, no mechanism that links a rupture in the Western Pacific to a rupture in the Gulf of Mexico on a time scale of hours. It is coincidence, dramatic, unsettling coincidence, but coincidence all the same. The planet is enormous, and on any given day, somewhere, the ground is breaking. What made this pairing feel like an omen is simply that both events were big enough to make the news on the same morning. What is real is the rarity. Step back and measure this against history. The strongest Gulf earthquake known before this one was likely a roughly magnitude 6.4 event near Veracruz, Mexico, back in 1959, and even that is uncertain, lost in the haze of older, cruder instruments. In the entire modern record, the Gulf has produced only a small handful of quakes at magnitude 5 or above. 5, maybe 6, in more than half a century of listening. Eastern Cuba, by contrast, sits much closer to that active boundary, and it has paid the price. A powerful magnitude, 7.7 struck between Cuba and Jamaica in 2020, exactly the kind of event the maps expect there. But this one, out in the quiet Western Gulf, far from the boundary, in a patch with no history at all, this was the anomaly, the one that wasn't supposed to be possible. The last time Florida felt the ground move was November 2024. Before that, you have to reach back years. These moments are genuinely uncommon there, which is part of why a 6.1 rattled buildings, emptied offices, and stayed in people's heads long after the shaking stopped. For a few seconds on June 8th, people who had never felt an earthquake in their lives, who never expected to, suddenly understood something the rest of the planet learns the hard way. That the ground is not fixed, that it only feels still, that somewhere beneath the calm, old wounds are still capable of opening. And the deepest unease isn't the quake itself, it's everything it implies. If a major earthquake can fire from a fault nobody knew existed in a region everyone assumed was safe, then how many other silent, forgotten fractures are sitting under places that have never felt a tremor? How many other quiet patches of crust are simply waiting for the right squeeze? Scientists don't have that map. Not yet. And that, more than the magnitude, more than the buildings, more than the 400-mile reach, is what makes this event impossible to dismiss. This is still being studied. The data is still coming in. The aftershocks may still be unfolding as you watch this. So here is the question to sit with, and the one to leave in the comments below. If a magnitude 6.1 can wake up out of a stable plate with no warning and no history, do you believe the place where you're standing right now is truly as safe as the maps say it is? Or do you think the ground beneath you might be hiding its own forgotten fault? Tell us where you are. Tell us if you felt this one, and tell us what you think is waking up next. Subscribe, because when the next update breaks, you'll want to be here for it.